Okay, good afternoon all of you. So in yesterday's lecture we have started the unit number 2, that is extended surfaces. Okay, so can anyone tell me what are the applications of the extended surfaces? Applications where we have to use the extended surfaces: electric motor bodies, then refrigerator, air conditioning, then next, what are the applications of the extended surfaces? Small काय काय त्याच्यामध्ये सांगा. Small capacity compressor is there. त्याच्यानंतर cylinder head is there. Okay. Okay. So what way the heat transfer takes place due to the convection. So what is the formula for the convection? Q is equal to HA into delta T. Okay. So what way we can increase the Q convection? So basically there are two ways: by increasing the surface area and by increasing the heat transfer coefficient. But for the increasing the heat transfer coefficient, there is a need of external device. Okay. So this approach is may or may not be practical. So therefore we can go for the to increase the surface area. And how to increase the surface area? For that we have to use the extended surfaces. Okay. So therefore we have to using the extended surfaces. Because of that, what will happen? The surface area will be increases and automatically Q convection will be increases. Okay. Then we have discussed about the applications. Okay. Equalizer for the steam power plant, then radiator of the automobile, air cooled engine, cooling coils and condenser coils in refrigerator and air conditioners, small capacity compressor, electric motor bodies, then transformer of electric equipments, and convector of for steam and hot water heating system. Okay, so these are the applications where we have to using the extended surfaces. After that, we have discussed about the types of the fin. Okay, so how many types are there? 4 types are there. First one is a first type. What is the first type of the extended surface? Rectangular. In rectangular, uniform cross section is there and non-uniform cross section is there. Then we have discussed about the circular. In circular, uniform, circular and non-uniform. Then annular fin is there, and last one is a splines. Okay, so these are the types of the fins or extended surfaces. Okay, after that we have discussed about the assumptions made in the analysis of the fins. So whatever the fin is there, we have to do the analysis on that fin. So we have to consider some assumptions. What are these assumptions? Steady state heat conduction, no heat generation within the fin, uniform heat transfer coefficient, homogeneous and isotropic fin material, negligible contact thermal resistance, one-dimensional heat conduction, and we have to neglecting the radiations. Okay, so we have to assume this condition, and on the basis of that we have analyzed that particular fins. Okay, then we have discussed about the formulas. Okay, so these are the some of the formulas which are required for the simplification. Okay, so these are the formulas. After that, we have started the derivation for the heat flow through the rectangular fin. So our aim is to calculate the Q, how much amount of heat is transferring through this rectangular fin. Okay, so for that we have considered the QX. QX is nothing but that much amount of heat is conducted into this small element. Okay, so this colorful element is nothing but small element. QX amount of heat is conducted into this element, and QX plus DX, that much amount of heat is conducted out from the element, and some heat will be convected into the surrounding, that is Q convection. So according to that we have written the equation. So what is the equation for the QX? That is Fourier's law of heat conduction, that is minus K into A into dt by dx. So we have written the equation for the QX. Similarly, we have written the equation for QX plus dx, that is QX plus derivative of QX into dx. Then we have written the equation for the convection. So what is the standard equation for the convection? That is H into A into delta T. So according to that we have written the equation. So what is the surface area? So whatever the small element we have considered, calculate the surface area of that particular small element. So what is the surface area? Dx into B plus Y into dx. So we have to take the 2 times, because at the upper side there is a surface, at the lower side same surface is there. Similarly for the left side, similarly for the right side. So therefore we have multiplied by the 2 for the each quantity. Okay, so from that we have calculated the AS, and what is the value of AS, that is perimeter into dx. So we have written the equation for the Q convection. So whatever the small element we have considered, for that we have written the energy balance equation, means how much heat will be coming into that element and how much heat is conducted and convected from that particular element. That is Qx is equal to Qx plus dx plus Q convection. So whatever the equations are there, we have put that value into this equation. Okay, so from that we get the equation as a d square T upon dx square minus Hp upon Ka T minus Ta is equal to 0. So in this equation we have considered that theta is equal to T minus Ta. So therefore that value we have to put it into this equation. So d square theta upon dx square is nothing but d square T upon dx square. So that value we have put it into equation 4. So therefore equation 4 becomes d square theta upon dx square minus Hp upon Ka theta is equal to 0. So we have considered that m square is equal to Hp upon Ka. So therefore we have written the equation as a d square theta upon d square minus m square theta is equal to 0. So from this equation, what is the value of m? Square root of Hp into Ka. Okay. So what is the solution for this equation 5? So there is a standard solution for this equation, that is theta is equal to C1 e raised to mx plus C2 e raised to minus mx. Okay. So in this equation, theta is nothing but T minus Ta. So we have put that value and we have considered the boundary condition. So what is the first boundary condition? At x is equal to 0, theta becomes theta 0, means T0 minus Ta. So this first boundary condition is same for the 3 cases. And what are that 3 cases? That is, it depends upon the physical situation. In first case, we have considered that fin is infinitely long. जे काय आपण fin connect केलेली आहे त्या सरफेसला, त्या फिनची लेंथ जर इन्फायनाइट असेल तर त्या केससाठी सेकंड बाउंड्री कंडिशन आपल्याला लिहायची आहे. सिमिलरली द एंड ऑफ द फिन इज इन्सुलेटेड. जी काय फिन आपण कनेक्ट केलेली आहे त्या फिनचा जर एंड आपण इन्सुलेटेड केला, सो व्हॉट इज द बाउंड्री कंडिशन फॉर दैट? देन सिमिलरली केस 3, द फिन इज ऑफ फाइनाइट लेंथ and loses heat from its end by the convection. So end आहे तिथून heat कशी लॉस होणार आहे? In the form of convection. So these are the 3 different cases. So according to that cases, we have to write down the second boundary conditions and we have to derive the equation for the Q for the each case. ज्या काही ह्या 3 केसेस आहेत त्या प्रत्येक केससाठी आपल्याला Q फाइंड आउट करायचा आहे. In yesterday's lecture, we have derived the equation for the case 1. So in that case, we have considered that the fin is infinitely long. Okay. So for that heat dissipation from an infinitely long fin, so we have drawn this diagram. So temperature is continuously reduces and at the end the temperature will be attained at the environment temperature or surrounding temperature. Okay. So according to that we have written the second boundary condition. This first boundary condition is same for the all 3 cases. पहिली जी boundary condition आहे ती तिन्ही केस साठी काय असणार आहे? सेम असणार आहे. Okay. And whatever the cases we have considered, according to that cases we have written the second boundary condition. Okay. So in this case we have considered that the fin is infinitely long. So therefore what is the second boundary condition? At x is equal to infinity, म्हणजे जो काही फिनचा एंड असणार आहे त्या ठिकाणी टेम्परेचर काय होणार आहे? सराउंडिंग टेम्परेचर असणार आहे. सो therefore at x is equal to infinity, t becomes Ta. So therefore theta becomes 0. Okay. So we have to put that, we have to apply this boundary condition and find out the values of C1 and C2. Okay. So first of all we have to put the first boundary condition. By putting the first boundary condition, we get the equation as a C1 plus C2 is equal to theta 0. Then we have put the second boundary condition and we get the equation as a C1 is equal to 0. So therefore what is the value of C2? C2 is nothing but theta 0. Okay. So put that values of C1 and C2 into the equation. So therefore we get the equation as a theta upon theta 0 is equal to e raised to minus mx. So what is the value of theta? T minus Ta. What is the value of theta 0? That is T0 minus Ta is equal to e raised to mx. So this is the equation for the temperature distribution. ज्या वेळेला fin ची length infinite असणार आहे, at that time how to calculate the temperature at any location? For that we have to use this temperature distribution equation. Okay. So by using this equation we can calculate the Q. Our aim is to calculate the rate of heat transfer. So therefore we have written the equation Q of fin is equal to minus K into A into dt by dx at x is equal to 0. म्हणजे त्या प्लेट मधून त्या फिन मध्ये किती हीट ट्रान्सफर होणार आहे? ती कुठे होणार आहे? ऍट द बेस ऑफ द फिन. सो देयरफॉर वी हैव कन्सिडर्ड dt by dx at x is equal to 0. Okay. So we get the equation of the temperature distribution, that is T minus Ta divided by T0 minus Ta is equal to e raised to minus mx. So by the simplification, we get the equation as a t minus t0 is equal to t0 minus t e raised to minus mx. So we have to take the derivative of this equation. We get the derivative as dt by dx at x is equal to 0 as t0 minus ta into minus m. So we have to put that value into the equation. So therefore q fin is equal to minus k into cross section area dt by dx at x is equal to 0. So in this equation we have to put this value. So therefore we get the equation for the q fin as a square root of p into h into k into cross section area into t0 minus ta. Okay, so this is the equation to calculate the rate of heat transfer when the length of the fin is infinite. समजलं का बघा, पहिल्या केस मध्ये आपण काय कन्सिडर केलेलं आहे, त्या फिनची लेंथ इनफायनाइट आहे. According to that, we have written the second boundary condition. By using that second boundary condition, we have calculated the values of C1 and C2, and from that we get the equation of the temperature distribution, and from that temperature distribution equation we have calculated the Q of the fin. And what is the final equation for the infinitely long fin? That is square root of P into H into K into A into T0 minus TA. So what is the meaning of P? P is nothing but perimeter. H is nothing but heat transfer coefficient. K is nothing but thermal conductivity of the fin. A CS is nothing but cross section area of the fin. T0 is nothing but temperature at the base of the fin, and TA is nothing but surrounding temperature. Okay, so by putting this value we can easily calculate the rate of heat transfer through the infinitely long fin. Okay, so this is the case 1. In yesterday's lecture we have solved one problem related to that. So in that problem they have mentioned that very long pieces, means they have not given the length of the fin. So they have mentioned that very long pieces. So therefore we have to consider that fin is having infinite length is there. So we have to consider the case 1. Okay, so according to case 1 we have solved that problem. So today we have to discuss the case 2. Okay, so all of you write down case 2. So in this case, whatever the fin is there, at the end we have to use the insulation. So काय end आहे तिथं काय असणार आहे, insulation असणार आहे. So we have to consider that insulation at the tip. So write down case 2. Case 2, heat dissipation from a fin. Heat dissipation from a fin. Heat dissipation from a fin insulated at the tip. Heat dissipation from a fin insulated at the tip. Okay, heat dissipation from a fin insulated at the tip. म्हणजे जो काय टीप आहे तो आपण काय करणार आहे, इन्सुलेट करणार आहे. पण ऍक्च्युअली मीनिंग काय बघा, एंड ऑफ द फिन इज जनरली not insulated. So here meaning that heat transfer from fin tip is negligible compared to the surface heat transfer. म्हणजे जो काही एंड असणार आहे तिथून जे काही हीट ट्रान्सफर होणार आहे ती निग्लिजिबल असते. सो दॅट्स व्हाय वी हॅव कन्सिडर्ड that end is insulated. Okay, म्हणजे जे काही ऍप्लिकेशन मध्ये आपण फिन यूज करतोय, so whatever the end is there, so at that end there is a negligible heat transfer is there. So therefore we have considered that end is insulated. Okay, since the heat transfer from the fin is proportional to its surface area, and the surface area of the fin tip is usually negligible fraction of the total fin area. आता जर एंडचा जर सरफेस एरिया बघितला आणि तुम्ही बाकीचा सरफेस एरिया बघितला तर एंडचा सरफेस एरिया काय एकदम स्मॉल आहे. सो therefore we have to neglect that particular heat. So that's why we have to considering that at the end there is a insulation. समजतंय का बघा, जो काही फिनचा बाकीचा सरफेस एरिया आहे त्याच्यापेक्षा जो एंडचा सरफेस एरिया तो काय एकदम लहान आहे. ओके, त्यामुळे तिथून जी काही हीट ट्रान्सफर होणार आहे ते एकदम स्मॉल असणार आहे. सो देअरफॉर वी हॅव टू कन्सिडरिंग दॅट ऍट द एंड देयर इज अ इन्सुलेशन. ओके, तिथून काहीतरी स्मॉल हीट ट्रान्सफर होते पण तो आपण काय करणार आहे, निग्लेक्ट करणार आहे. पण निग्लेक्ट करणार आहे म्हणजे आपण त्याला काय म्हणणार आहे, दॅट एंड इज इन्सुलेटेड. इन्सुलेटेड असेल तर हीट ट्रान्सफर होणार नाही. ओके, सो दॅट्स वाय वी हॅव टू कन्सिडरिंग द इन्सुलेशन ऍट द वन टिप. सो दिस इज द केस 2. ओके, जी काय प्लेट आहे त्याला आपण एक फिन अटॅच करणार आहे आणि त्या फिनचा जो काय एंड आहे तो आपण कसा कन्सिडर करणार आहे, दॅट एंड इज इन्सुलेटेड. ओके, पहिल्या केस मध्ये आपण काय कन्सिडर केलं तर जी काय प्लेट असणार आहे त्याला जी काय फिन आपण अटॅच करणार आहे दॅट फिन इज इनफायनाइटली लॉंग. ओके, सो इन दिस केस वी हॅव टू कन्सिडर व्हॉटएव्हर द फिन इज देअर, व्हॉटएव्हर द एंड ऑफ द फिन इज देअर, वी हॅव टू कन्सिडर दॅट एंड इज insulated. Okay, so we have to consider that case 2. So all of you draw this diagram for this case 2. Okay, So at the end there is a insulated end. So therefore dt by dx at x is equal to L, it is 0. Heat transfer होणार नाही त्या end मधून. So therefore we have to consider dt by dx at x is equal to L is equal to 0. Okay. So T0 is nothing but base temperature which is at x is equal to 0. Okay. So this is the temperature profile for that particular fin, and at the end we have to insulate it. So therefore the heat transfer will be not taking place. So therefore the temperature change with respect to thickness at the end, it becomes 0. Okay, so all of you complete this diagram. We have to consider the length of the fin as a capital L. Okay, base temperature is T0. Along the x direction, the heat transfer takes place. Okay, so from this, what is the temperature at the end? So at the end, we are using the insulation. So therefore, at the end, the change in temperature with respect to thickness, that value becomes 0. Okay, so diagram is over. So what is the length of the fin? That is capital L, and whatever the end of the fin is there, we have to insulate that end. So therefore the heat transfer is not taking place due to the insulation. So therefore change in temperature with respect to thickness at that end, that value becomes 0. Okay, so now write down the boundary conditions. So our aim is to calculate the values of C1 and C2. So as we know that first boundary condition is same for the 3 cases. So already we have discussed the case 1. Now we have to discuss in the case number 2. So first boundary condition is same. That is at x is equal to 0, t becomes t0. So therefore theta becomes theta 0. And what is the value of theta 0? That is t0 minus ta. Okay, at x is equal to 0, what is the temperature? That is T0. So instead of T, we have to put the value of T0. Okay, similarly, what is the second boundary condition? At x is equal to L, at x is equal to L, so that d theta by dx is nothing but what is the value of theta, t minus ta. Okay, so that both values are constant. So therefore dt by dx is equal to 0, because at the end heat transfer is not taking place. So therefore dt by dx become 0. Okay, so this is the second boundary condition. So whatever the condition we have considered, at the end there is a insulation. According to that insulation, we have written the second boundary condition at x is equal to L. At the end, insulation asnara, therefore heat transfer is not taking place. So therefore change in temperature with respect to thickness, that value become 0. Okay, so what is our governing equation? Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. So this is the equation number 1. Okay, so in this equation we have to put the boundary conditions. We have to put the boundary conditions. Okay, so put the first boundary condition. By putting the first boundary condition, काय इक्वेशन येते काल आपण पुट केलेलं आहे. Applying the first boundary condition, काय येते इक्वेशन C1 plus C2 is equal to theta 0. Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. This is the equation 1. So apply first boundary condition to governing equation. Okay, so by putting the first boundary condition, we get the equation as a C1 plus C2 is equal to theta 0, and that is the equation 2. पहिली boundary condition put केल्यानंतर काय येते equation? Theta 0 is equal to C1 plus C2. theta 0 is equal to C1 plus C2. After that, we have to put this second boundary condition. Okay, so how to apply the second boundary condition? काय करावं लागेल बघा. सेकंड बाउंड्री कंडिशन मध्ये आपण काय म्हटलंय, at x is equal to L, dt by dx is equal to 0. Okay, so what is our equation 1? Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. So how to apply the second boundary condition in equation 1? काय करावं लागेल सांगा. How to apply the second boundary condition for the equation 1? So in this equation, dt by dx is there. Okay, so what is the value of theta? Theta means what? T minus Ta. So we have to calculate the value of dt by dx and then apply the second boundary condition. Okay, so write down, apply second boundary condition. So what is our equation? Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. But what is the value of theta? Theta is nothing but T minus Ta. Okay, so we have to put that value. T minus Ta is equal to C1 e raised to mx plus C2 e raised to minus mx. Okay, so we have to take the differentiation of equation at x is equal to L and equate it 0. Okay, so we have to take the differentiation of this equation so that we get the equation for the dt by dx. Okay, so differentiate above equation. काय ना सांगायचं डेरिव्हेटिव्ह t minus ta चं डेरिव्हेटिव्ह काय असणार आहे dt by dx. Then what is the derivative of e raised to mx? E raised to mx into m. And what is the derivative of e raised to minus mx? E raised to minus mx into minus m. Okay, so all of you write down, dt by dx is equal to c1 e raised to mx into m plus c2 e raised to minus mx into minus m. Okay, so we have to calculate the dt by dx at x is equal to L. So therefore, instead of x, we have to put the value of L. Okay, so dt by dx at x is equal to L is equal to C1 e raised to ml into m plus C2 e raised to minus ml into minus m is equal to 0. Okay, असं आपण का केलेलं आहे, 0 का घेतलेला आहे, तर इथं बाउंड्री कंडिशन आपण काय कन्सिडर केलेली आहे, dt by dx is equal to 0. कधी dt by dx is equal to 0 आहे, when x is equal to L. So therefore we have put the value as a instead of x, that is L, and we have equated that value to the 0. Okay, so from equation 2, जे काय आपले equation 2 आहे, so from the equation 2 काय बघा, theta 0 is equal to C1 plus C2. So from that equation, how to write the value of C2? C2 is nothing but theta 0 minus C1. हे समजते का बघा, जे काही equation 2 आहे, what is the equation 2? Theta 0 is equal to C1 plus C2. So what is the value of C2? C2 is nothing but theta 0 minus C1. So whatever the equation we got, so in this equation, instead of C2, we have to put the value as a theta 0 minus C1. हे जे आपण equation consider केलेलं आहे, in this equation, instead of C2, we have to put the value theta 0 minus C1. C2 च्या जागेला काय पुट करायचं आहे, theta 0 minus C1. Okay, so we have to put that value. So by putting the value, we get the equation as a C1 e raised to ml into m minus C2 is there. So instead of C2, we have put the value as a theta 0 minus C1 e raised to minus ml into m is equal to 0. So we have to simplify this equation. So by simplifying, C1 e raised to ml into m minus theta 0 into e raised to minus ml into m plus C1 e raised to minus ml into m is equal to 0. Okay, so whatever the C1 terms are there, we have to take at the left hand side, and remaining terms we have to take at the right hand side. Okay, so C1 terms are C1 e raised to ml into m plus C1 e raised to minus ml into m. Theta 0 is equal to theta 0 e raised to minus ml into m. So take the C1 as a common. So what is the remaining equation? E raised to ml plus e raised to minus ml is equal to theta 0 into e raised to minus ml. Okay, so m is common in the both sides, so therefore m will be cancelled. So what is the remaining equation? So C1 is equal to theta 0 into e raised to minus ml upon e raised to ml plus e raised to minus ml. All of you get this value. What is the value of C1? C1 is equal to theta 0 into bracket e raised to minus ml divided by e raised to ml plus e raised to minus ml. Okay, and we have this equation. What is this equation? C2 is equal to theta 0 minus C1. So in this equation, we have to put the value of C1 and find out the value of C2. Okay, C2 is equal to theta 0 minus C1. So therefore, we get the value of C1, put that value into this equation and find out the value of C2. So C2 is equal to theta 0 is common. So 1 minus e raised to minus ml divided by e raised to ml plus e raised to minus ml. समजले का बघा इथं C1 मध्ये पण theta 0 आहे आणि इथं पण theta 0 आहे. So therefore theta 0 is common. So what is the remaining? 1 minus e raised to minus ml divided by e raised to ml plus e raised to minus ml. Okay, so do the simplification on this bracket. So by simplification we get the equation as a C2 is equal to theta 0 into bracket e raised to ml divided by e raised to ml plus e raised to minus ml. इथं बघा e raised to minus ml minus e raised to minus ml. So this term will be cancelled. So only remaining term is e raised to ml. Okay, so what is the final value of C2? C2 is equal to theta 0 into bracket e raised to ml divided by e raised to ml plus e raised to minus ml. Okay, so we get the values of C1 and C2. So put that values into the governing equation. So what is our governing equation? Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. So in this equation, we have to put the values of C1 and C2. या equation मध्ये C1 आणि C2 च्या values put करा. So therefore equation becomes theta is equal to theta 0 into bracket e raised to minus ml divided by e raised to ml plus e raised to minus ml into e raised to mx plus theta 0 into what is the value of C2, that is e raised to ml divided by e raised to ml plus e raised to minus ml into e raised to minus mx. Okay, C1 आणि C2 ची value इथं put करा. Okay, इथपर्यंत झालं सगळ्यांचं. Okay, so whatever this C1 and C2 is there, we have to put that values of C1 and C2 in the governing equation. Okay, so what is our governing equation? Theta is equal to C1 e raised to mx plus C2 e raised to mx. So put the value of C1 and C2 in this equation. Okay, then simplify that equation. So theta 0 is common in the right hand side. So therefore we have to take that in the left hand side. So therefore theta upon theta 0 is equal to e raised to minus ml into e raised to mx. एक्सपोनेन्शियल जर प्रोडक्ट असेल तर काय करतोय आपण ऍडिशन करतोय. सो e raised to minus ml plus mx divided by e raised to ml plus e raised to minus ml plus in another bracket e raised to ml minus mx divided by e raised to ml plus e raised to minus ml. Okay, then simplify that equation. So theta upon theta 0 is equal to e raised to m is common, so minus m into bracket l minus x divided by e raised to ml plus e raised to minus ml plus into another bracket e raised to m into bracket L minus m इथे काय चुकले सांगा m into bracket काय पाहिजे L minus x पाहिजे ओके इथे x लिहा divided by e raised to ml plus e raised to minus ml okay so denominator is common so therefore write down the equation theta upon theta 0 is equal to e raised to minus m into bracket L minus x plus e raised to m into bracket L minus x divided by e raised to ml plus e raised to minus ml denominator is same आहे so therefore we have to take the common and whatever the numerators are there we have to do the addition okay so theta upon theta 0 is equal to e raised to minus m into bracket L minus x plus e raised to m into bracket L minus m divided by e raised to ml plus e raised to minus ml okay in next step we have to divide numerator and divide denominator by the 2 numerator आणि denominator ला 2 ने divide करा so what is the equation theta upon theta 0 is equal to e raised to minus m into bracket L minus x plus e raised to m into bracket L minus x divided by 2 divided by e raised to ml plus e raised to minus ml by 2 okay तर आपण काल फॉर्म्युले लिहिलेले आहेत so from that formulas what is the instead of this e raised to minus m L minus x plus e raised to m into bracket L minus x by 2 त्याच्या जागेला आपण काय लिहू शकतो सांगा काल फॉर्म्युलेस तुम्हाला लिहून दिलेले आहेत see that formulas so instead of that e raised to term what we put काय येणार आहे numerator ला काय येणार denominator ला काय येणार सांगा what is the value at the numerator what is the value at the denominator कालच्या आन्सर मध्ये असा फॉर्म्युला आहे का बघा e raised to minus mx plus किंवा e raised to minus x plus e raised to x by 2 कशाचा फॉर्म्युला आहे तो cos hyperbolic x पण इथं काय घ्यावं लागेल cos hyperbolic काय येणार इथं काय x म्हणजे काय येते टर्म बघा डिनॉमिनेटर काय येऊ शकते सांगा e raised to x plus e raised to minus x divided by 2 कशाचा फॉर्म्युला आहे cos hyperbolic x बरोबर मग इथं काय येणार आहे इथं ml आहे आपण x कन्सिडर करतोय म्हणजे इथं cos hyperbolic ml येणार ओके सो इन दॅट वे वी हॅव टू राइट डाउन theta upon theta 0 is equal to t minus ta divided by theta म्हणजेच काय theta is nothing but t minus ta and theta 0 is nothing but t0 minus ta okay so whatever the numerator is there so instead of that numerator what is the value cos hyperbolic m into bracket L minus x and similarly for the denominator cos hyperbolic ml is there okay so this is the temperature distribution equation for the insulated fin at the tip ज्यावेळेला tip insulated असणार आहे at that time we have to use this equation for the finding the values of temperature distribution okay so this is the temperature distribution equation by using this we have to calculate the rate of heat transfer the rate of heat transfer साठी आपण कुठले इक्वेशन यूज करणार सांगा रेट ऑफ हीट ट्रान्सफर कुठल्या लोकेशनला आपण फाइंड आउट करतोय ऍट दी बेस. ओके, सो व्हॉट मोड ऑफ हीट ट्रान्सफर इज देअर, कंडक्शन इज देअर. जी काय प्लेट आहे आणि तिथं आपण ही फिन कनेक्ट केलेली असणार आहे, त्या फिनचा जो बेस आहे तिथे काय होणार आहे, कंडक्शन होणार आहे. ओके, सो Q इज इक्वल टू मायनस K इंटू dt बाय dx ऍट व्हॉट, ऍट x इज इक्वल टू 0. ओके, तिथं कंडक्शन होणार आहे. या प्लेट मधून या फिन मध्ये जिथे हीट ट्रान्सफर होणार आहे ते लोकेशन म्हणजे काय असणार आहे, x इज इक्वल टू 0. सो देअरफॉर heat transfer rate is nothing but Q fin is equal to minus K into A cross section area into dt by dx at x is equal to 0. समजले का बघा, ते x is equal to 0 आपण का घेतोय. ओके, जी काय प्लेट आहे व्हर्टिकल प्लेट त्याला आपण फिन कनेक्ट केलेली आहे. फिनचा जो काय बेस असणार आहे तो ते आपण प्लेटला कनेक्ट करतोय, पण तो जो काय फिनचा बेस आहे तो कुठे आहे, ऍट x is equal to 0 ह्या लोकेशनला आहे. सो देअरफॉर वी हॅव टू कन्सिडर dt by dx at x is equal to 0. Okay, so whatever the temperature distribution equation is there, so from that we have to calculate the dt by dx at x is equal to 0. Equation ले लेगा, Q fin is equal to minus K into cross section area dt by dx at x is equal to 0. Okay, so what is our temperature distribution equation for the insulated tube? So all of you write down that equation, and by using that equation we have to calculate the value of dt by dx at x is equal to 0. समजते का बघा, जे काय आपल्याला टेम्परेचर डिस्ट्रीब्युशनचे इक्वेशन मिळालेलं आहे, बाय युजिंग दिस इक्वेशन वी हॅव टू कॅल्क्युलेट द व्हॅल्यू ऑफ dt by dx at x is equal to 0. Okay, so first of all rewrite this equation. So how to rewrite this equation, t minus ta is equal to T0 minus Ta into bracket cos hyperbolic m into bracket L minus x divided by cos hyperbolic ml. So we have to take the derivative of this term. So therefore we get the value of dt by dx, and in that equation we have to put the value of x as a 0. Okay. T minus Ta is equal to T0 minus Ta cos hyperbolic m into bracket L minus x divided by cos hyperbolic ml. Okay, तर याचे डेरिव्हेटिव्ह घ्या. सो व्हॉट इज द डेरिव्हेटिव्ह ऑफ लेफ्ट हँड साइड, दॅट इज dt by dx. आता डेरिव्हेटिव्ह आपण विथ रिस्पेक्ट टू काय घेणार आहे, विथ रिस्पेक्ट टू x. सो देअरफॉर इन द डिनॉमिनेटर देयर इज ए x value is not there, so denominator also constant. Okay, so x is present only in the cos hyperbolic m into bracket L minus x. So what is the derivative of cos hyperbolic x? काय असतंय, काल दिलाय फॉर्म्युला तुम्हाला लिहून. व्हॉट इज द डेरिव्हेटिव्ह ऑफ cos hyperbolic x sin hyperbolic x. ओके, सो राइट डाउन इन दैट फॉर्म. सो dt by dx is equal to T0 minus Ta. Derivative of cos hyperbolic x is nothing but sin hyperbolic x, but in this case what is the value of x, that is m into bracket L minus x. Okay, so whatever the value is there we have to take the, काय करायला लागते सांगा, परत काय करावं लागतं, त्याचं जो काही x असणार आहे हा जो m आहे m इंटू काय x असणार आहे, म्हणजे मायनस mx इज देअर. सो वी हॅव टू टेक दॅट कॉन्स्टंट आउटसाइड. ओके, सो मीन्स वी हॅव टू टेक इन द अगेन डेरिव्हेटिव्ह. सो देअरफॉर वी गेट द व्हॅल्यू एज ए मायनस m. सो वी हॅव टू मल्टिप्लाय बाय द मायनस m. माहिती आहे का बघा हे सगळ्यांना. डेरिव्हेटिव्ह ऑफ cos hyperbolic x is nothing but sin hyperbolic x, and whatever the value of x is there we have to take again derivative of that, means x having multiplied by the m is there, so minus mx is there. So what is the derivative of minus mx? काय असते, what is the derivative of minus mx? Minus m. So therefore we have multiplied by the minus m. Okay, so our aim is to calculate the dt by dx at x is equal to 0. So therefore in this equation we have to put the value of x as a 0. So write down dt by dx at x is equal to 0. So in this equation instead of x we have to put the value as 0. Okay, so therefore dt by dx at x is equal to 0, T0 minus Ta sin hyperbolic m into L minus 0 into minus m divided by cos hyperbolic ml. साइन हायपरबोलिक ml डिवायडेड बाय कॉस हायपरबोलिक ml काय येणार सांगा. साइन डिवायडेड बाय कॉस काय असतं tan. Okay, so in that way write down dt by dx at x is equal to 0 t0 minus ta sin hyperbolic ml into minus m divided by cos hyperbolic ml. So sin hyperbolic ml divided by cos hyperbolic ml is nothing but tan hyperbolic ml. Into minus m is there. Okay, so whatever the value of dt by dx at x is equal to 0, we have to put that value into equation of q fin. So what is the equation of q fin? Minus k into a into dt by dx at x is equal to 0. So in that equation we have to put this value. So the equation becomes q fin is equal to minus k into a into dt by dx at x is equal to 0. तर ही dt by dx at x is equal to 0 ची व्हॅल्यू आपण इथे पुट केलेली आहे. So therefore equation becomes q fin is equal to minus k into cross section area t0 minus ta tan hyperbolic ml into minus m. So that minus minus become plus. So therefore equation is nothing but q fin is equal to k into a into t0 minus ta tan hyperbolic ml into m. Okay, but what is the value of m? m ची व्हॅल्यू काय आहे सांगा. What is the value of m? Square root of hp upon ka. Okay, so put that value of m into this equation. Square root of hp upon k into a. m ची व्हॅल्यू आपल्याला माहिती आहे. We have considered that m as a square root of hp upon k into cross section area. Okay, so by the simplification we get the equation as a q fin is equal to square root of phk a tan hyperbolic ml into t0 minus ta. हे समजलं का बघा. इथं k इंटू क्रॉस सेक्शन एरिया आहे स्क्वेअर रूट मध्ये आणि इथं k इंटू क्रॉस सेक्शन एरिया म्हणजे इथं 2 times square root is there, so one square root will be cancelled, so we get the equation as a square root of p into h into k into cross section area. ओके, इथं लक्षात ठेवा या डॉट पासून हे t0 minus ta हे सेपरेट आहे. tan हायपरबोलिक घेताना फक्त ह्या दोन्हीचं प्रोडक्ट घेऊन त्याचं tan हायपरबोलिक घ्यायचं आहे. नाहीतर हे सगळ्याचं प्रोडक्ट घेशील आणि परत tan हायपरबोलिक घेशील ते रॉंग होणार आहे. ओके, so all of you remember this thing. Q fin for the tip of the fin is insulated. Okay, so how to calculate the rate of heat transfer when the tip of the fin is insulated? So at that time we have to use this equation and find out the rate of heat transfer. Okay, so this is the case 2. समजले का बघा. So write down the problem on this for the case 2. Write down the problem. Find out the amount of heat transferred Find out the amount of heat transferred through an iron fin of length 50 mm, width 100 mm and thickness 5 mm. Find out the amount of heat transferred through an iron fin of length 50 mm, width 100 mm and thickness 5 mm. Assume K is equal to 210 watt per meter degree Celsius and H is equal to 42 watt per meter square degree Celsius. For the material of fin, for the material of fin, for the material of the fin, for the material of the fin, and the temperature at the base of the fin as 80 degrees Celsius. And the temperature at the base of the fin as a 80 degrees Celsius. Also determine the temperature at the tip of the fin. Also determine the temperature at the tip of the fin when atmospheric temperature 20 degrees Celsius. When atmospheric temperature 20 degrees Celsius. ओके, तर ही केस कुठली असणार आहे? केस 1, केस 2. याच्यामध्ये इन्फायनाइटली लॉंग किंवा लॉंग असे वर्ड आहेत का? ओके, सो दिस इज नॉट ए एक्झाम्पल ऑफ केस 1. ओके, याच्यानंतर आपण केस 3 कन्सिडर करणार आहे. इन दॅट केस देयर इज ए कन्व्हेक्शन हीट ट्रान्सफर इज देयर, but in this case also they have not given the convection heat transfer, so therefore we have to understand this is the case number 2. ओके, इथं आपल्याला इन्फायनाइटली लॉंग पण मेन्शन केलेलं नाही किंवा हीट ट्रान्सफर ड्यू टू द कन्व्हेक्शन इज देयर असं पण म्हटलेलं नाही. सो देअरफॉर वी कॅन गो फॉर द केस नंबर 2. ओके, सो व्हॉट इज द रेट ऑफ हीट ट्रान्सफर फॉर द केस 2? दॅट इज इक्वेशन आहे बघा इथं, स्क्वेअर रूट ऑफ P into H into K into क्रॉस सेक्शन एरिया tan hyperbolic ml into bracket T0 minus TA. ओके, सो विच क्वांटिटीज आर अननोन? P माहिती आहे का आपल्याला? पेरिमीटर कॅल्क्युलेट करावं लागेल. H दिलाय का? H इज गिवन, K इज गिवन, क्रॉस सेक्शन एरिया कॅल्क्युलेट करावा लागेल. tan hyperbolic ml, ओके, m कॅल्क्युलेट करावं लागेल. ओके, T0 is given, TA is given. Okay, so first of all we have to calculate the perimeter and cross section area, and by using that we can calculate the square root. But how to calculate the value of m? So m is nothing but square root of pH upon K. So in that also there is a requirement of P and cross section area. So therefore first of all we have to calculate the values of P and cross section area. Okay, so all of you write down the given. So what is the length of the fin? That is capital L is equal to 50 mm. So we have to convert that mm into meter. So therefore 0.05 meter. Then width is given 100 mm, means B is given. So B is 100 means B is equal to 0.1 meter. Thickness, that is Y is given. So Y is 5 mm. So we have to convert into meter. B is 100 mm. So we have to convert into meter. That is 0.1 meter. Thickness is given 5 mm. So we have to convert into meter. So therefore 0.005 meter. Then K is given. K is 210 watt per meter degree Celsius. K is equal to 210 watt per meter degree Celsius. K is equal to 210 watt per meter degree Celsius. H is given 42 watt per meter square degree Celsius. H is given 42 watt per meter square degree Celsius. T0 is given, base temperature that is 80 degrees Celsius. Then surrounding air temperature is given, that is 20 degrees Celsius. Okay, so first of all we have to calculate the perimeter. Okay, so how to calculate the perimeter? Okay, the rectangular fin hai. So whatever the diagram we have drawn, according to that we have to take the perimeter. So what is the perimeter for the rectangular fin? That is P into bracket P is equal to 2 into bracket B plus Y. Okay, आपण जी काल डायग्राम ड्रॉ केलेली त्याच्यावरती दाखवलेला आहे पेरिमीटर 2 into B plus Y. So B is given, Y is given. So put that value. So we get the value of perimeter, that is 0.21 meter. Okay. Similarly, we have to calculate the value of cross section area. So what is the value of cross section area? That is B into Y. Okay, so B is 0.1, Y is 0.05. So therefore, cross section area is nothing but 0.0005 meter square. Okay, so we have calculated the value of P and cross section area. Then for the calculation of Q, there is a need to calculate the value of M. So what is the formula for M? M is nothing but square root of P into H divided by K into cross section area. So in this equation, we have to put the values of P, H, K and M and find out the value of M. Okay. So all of you put the values into this equation and tell me what is the answer for the M. Try to सांगा what is the value of M? $9.16. येते का बघा सगळ्यांचं M is equal to 9.16, 9.165. Okay, perimeter is 0.21, H is 42, K is 210, cross section area is 0.005. So by simplification, we get the value of M as a 9.165. 9.165. Okay, so our aim is to calculate the Q fin. So what is the equation of the Q fin? Square root of P into H into K into cross section area into tan hyperbolic ML into T0 minus TA. Okay, so all of you put the values into this equation and find out the value of Q fin. काय ते सांगा Q fin. काय ते बघा Q fin. काय ते Q fin. Anyone got the answer? इकडे लक्ष द्या, हे टर्म सेपरेट आहे. टॅन हायपरबोलिक ML ही सेपरेट टर्म आहे. त्याच्यानंतर T0 मायनस TA ही सेपरेट टर्म आहे. नाहीतर हे टॅन हायपरबोलिक मध्ये याचा प्रोडक्ट घेशील आन्सर रॉंग येणार आहे. सेपरेटली यू हॅव टू फाइंड आउट दिस स्क्वेअर रूट ऑफ P into H into K into cross section area. Then we have to find out the value of tan. First of all, you have to calculate the value of M into L and then take the tan hyperbolic of that value. Okay, and then we have to calculate the value of T0 minus TA and take the product of these three values. सांगा तुमचं काय आलं? चुकू द्या, सांगा काय असेल. 0.46. आणखी कोणा चालेल? 0.46. 6 पॉइंट प्रमोद किती? 0.46. 24.75. आणखी कोणाचं? 57. वेगवेगळे आन्सर आले सगळ्यांचे. कॅन हायपरबोलिक, म्हणूनच मी ते आन्सर दाखवलं नाही ना, तुम्ही लिहून घेतला असतं कॅल्क्युलेशन केलं नसतं. $24 कोणी सांगितलेलं? प्रतीक, तुमचं बरोबर आहे. 24.75. कॅन हायपरबोलिक करता येत नाही का कॅल्क्युलेटर वरती? कॅल्क्युलेटर द्या भाऊ मला. तुम्हाला हायपरबोलिक कधीच केलं नव्हतं का आतापर्यंत? विराज आलाजी हायपरबोलिक यूज केलं नाही आधी कधी? कॅल्क्युलेटर वरती कॅल्क्युलेशन ना, म्हणजे नुसतं जर प्रॉब्लेम बघितला असता, आन्सर लिहून घेतला असतं तर एक्झाम मध्ये कळालंच नसतं हायपरबोलिक काय. आले का आता? तुम्हालाच आठवत नाही म्हणजे अवघड झालं. Okay, so this is the value of Q fin. So this much amount of heat transfer will be takes place. That is 24.75 watt. So what is the next value? Also determine the temperature at the tip of the fin. जो काही टीप असणार आहे तिथलं टेम्परेचर तुम्हाला फाइंड आउट करायचं आहे. सो हाऊ टू फाइंड आउट दॅट टेम्परेचर? कसं फाइंड आउट करावं लागेल सांगा? सो वी हॅव वन इक्वेशन, टेम्परेचर डिस्ट्रीब्यूशन इक्वेशन इज देयर. Okay, so this is the equation of the temperature distribution. So in this equation our aim is to calculate the value of T when x is equal to what? At the tip म्हणजे काय असणार? x ची व्हॅल्यू काय होणार सांगा? At the tip of the fin, what is the temperature? Means what is the value of x? बेसला x is equal to काय असते? 0 असते, पण टिपला काय असते? x is equal to L असते. So therefore आणि टी फाइंड आउट करायचा आहे. ओके, m आपल्याला माहिती आहे, L is given to us. So instead of x we have to put the L. Okay, so cos hyperbolic 0 काय असते? काल दिले का बघा व्हॅल्यू cos hyperbolic 0 काय असते? cos hyperbolic 0 1. Okay, so put that values and find out the value of T. Temperature at the tip of fin means x is equal to L. So therefore instead of x we have to put the value of L. So therefore T minus 20 divided by 80 minus 20 is equal to so cos hyperbolic 0 is there. So therefore that value becomes 1. So we get the equation as a T minus 20 divided by 60 is equal to 1 divided by cos hyperbolic ml. Okay, simplify करा. then we get the value of T. इथं फाइंड आउट करा cos hyperbolic ML. M माहिती आहे, L माहिती आहे. Take the cos hyperbolic of that, put that value and find out the T. आन्सर येते का बघा, चेक करा. 74 येते. आले सगळ्यांचा आन्सर 74.21. ओके. Okay, then write down the case 3. Case 3. Fin of finite length losing heat from its end by the convection. So whatever the end of the fin is there, so here heat transfer takes place due to the convection. So we have to consider in that case fin of finite length, fin of finite length losing heat from its end, fin of finite length losing heat from its end by convection, losing heat from its end by convection, losing heat from its end by convection. Okay, so all of you draw this diagram. Okay, त्या फिनला काहीतरी लेंथ असणार आहे, फायनाइट लेंथ म्हटलेला आहे. ओके, so that fin have some length is there, so we have to consider the length as a capital L. Okay, तर हा जो एंड असणार आहे, whatever the end of the fin is there, the heat transfer takes place due to the convection. Okay, म्हणजे जी काही हीट या फिन मधून कंडक्ट होणार आहे up to this end, then that heat will be transferred into the surrounding due to the convection. So that's why we have written the equation as a, this heat is conducted into the end. इकडून काय होणार आहे, हीट कंडक्ट होत x is equal to L पर्यंत काय होणार आहे, हीट कंडक्ट होणार आहे. and from this end heat is convected, म्हणजे जी काही कंडक्ट होऊन हीट येणार आहे तीच हीट काय होणार आहे, कन्वेक्ट होणार आहे. so Q conduction is equal to convection at the end. so therefore we written the equation as a minus K into dt by dx is equal to HA into delta T. Okay, at the end काय होणार आहे, whatever the heat is conducted, that heat will be convected into the surrounding. So therefore Q conduction is equal to Q convection. So what we have written the equation of the Q conduction as K into A into dt by dx at x is equal to L, because this location is nothing but at x is equal to L. Okay, similarly what is the convection heat transfer, how to calculate the convection heat transfer coefficient, that is HA delta T. Okay, so T is nothing but temperature at any time and TA is nothing but temperature of the surrounding. आणि इथं ASU म्हणजे काय असणार आहे, सरफेस एरिया असणार आहे. पण कुठला सरफेस एरिया असेल सांगा. ओके, जो काय फिनचा एंड असणार आहे, हा फिनचा एंड असणार आहे. इकडून ह्या जे काय आपण फिन कन्सिडर केलेले आहे त्याच्यामधून काय होणार आहे, हीट ट्रान्सफर होणार आहे ती ह्या एंडला येणार आहे. ह्या एंड पर्यंत हीट येणार आहे, म्हणजे ते कुठल्या मोड मध्ये येणार आहे, कंडक्शन मोड मध्ये येणार आहे. पण इथून हीट काय होणार आहे, ट्रान्सफर होणार आहे इन दी एअर ड्यू टू दी कन्वेक्शन. सो व्हॉट एव्हर दी हीट इज कंडक्टेड ऍट दी एंड, that much amount of heat is convected into the surrounding. Okay, so therefore Q conduction is equal to Q convection. So what is the equation of the Q conduction, that is K into dt by dx. and what is the equation of the Q convection, that is HA into delta T. फक्त हा एरिया कुठला घ्यावा लागेल, हा जो सरफेस असणार आहे त्या सरफेसचा एरिया तुम्हाला घ्यावा लागेल, ASU. तिथे डायग्राम मध्ये दिलेला आहे. ASU म्हणजे काय असणार आहे, हा सरफेस एरिया असणार आहे जिथून काय होणार आहे, हीट ट्रान्सफर होणार आहे. ओके, सो फर्स्ट बाउंड्री कंडिशन सेम असणार आहे. सो व्हॉट इज द फर्स्ट बाउंड्री कंडिशन, राइट डाउन at x is equal to 0, t is equal to 0, t0, theta is equal to theta 0, that is t0 minus ta. At x is equal to 0, t is equal to 0. So whatever the three cases we have considered, the first boundary condition is same. पहिली boundary condition तिन्हीसाठी काय आहे तर same आहे. Only difference in the second boundary condition. So whatever the physical situation we have considered, according to that we have written the second boundary condition. So in this case, at the end, we have considered that heat is transferred due to the convection. So according to that, we have written the boundary condition. Okay. So what is the second boundary condition? At x is equal to L. At x is equal to L म्हणजे काय असणार आहे, तो फिनचा एंड आहे. Here heat is conducted to the tip of the fin must be equal to the heat convected away from tip to the ambient air. Okay. So heat conducted कशी फाइंड आउट करते आपण, K into A into dt by dx. So dt by dx कुठला फाइंड आउट करायचा आपल्याला, at the end of the fin. So therefore x is equal to L. dt by dx at x is equal to L and h into A into t minus ta. ओके, आता इथे मला कोणी सांगू शकते का, क्रॉस सेक्शन एरिया आणि सरफेस एरिया हे दोन्ही सेम असतील का वेगळे असतील? एनीवन? So in the conduction we have taken the ACS, area cross section area, and in the convection we have considered that ASU, that is surface area. Whether these two areas are same or different? Conduction मध्ये आपण कुठला एरिया कन्सिडर करतोय सांगा? The area which is normal to the direction of heat flow. म्हणजे ही जी प्लेट आहे, ही जी फिन आपण अटॅच केलेली आहे त्या बेसला, त्या फिन मधून काय होणार आहे, कंडक्ट हीट होणार आहे. म्हणजे ह्याचा क्रॉस सेक्शन एरिया म्हणजे हाच एरिया असणार आहे, लक्षात ठेवा. समजते का? त्या डायरेक्शन मध्ये हीट ट्रान्सफर होते, म्हणजे परपेंडिक्युलर टू द डायरेक्शन ऑफ हीट फ्लो, म्हणजे हा सरफेस असणार आहे, म्हणजेच हा सरफेस असणार आहे. आणि कन्व्हेक्शन मध्ये पण आपण काय कन्सिडर केलेला आहे, सरफेस एरिया, म्हणजे हा सरफेस एरिया कन्सिडर केलेला आहे जिथून हीट सराउंडिंग मध्ये ट्रान्सफर होणार आहे. म्हणजे ह्या केस मध्ये काय असणार आहे, so what is the governing equation? Write down the governing equation. Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. Governing equation, theta is equal to C1 e raised to mx plus C2 e raised to minus mx. This is the equation 1. तर आपण पहिली बाउंड्री कंडिशन पहिल्या दोन्ही केस मध्ये अप्लाय केली, त्यावेळेला आपल्याला इक्वेशन काय मिळालेलं आहे, theta 0 is equal to C1 plus C2. So directly we have to write down that equation. Apply first boundary condition. Apply first boundary condition. So we get the theta 0 is equal to C1 plus C2, that is equation 2. Apply first boundary condition. Theta 0 is equal to C1 plus C2. This is the equation 2. Now we have to consider the second boundary condition. Okay. So heat conducted at x is equal to L. So we have to write down the equation. Heat conducted equation at x is equal to L, that is minus K into cross section area into dt by dx at x is equal to L. So this much amount of heat is conducted at x is equal to L. This much amount of heat is conducted at x is equal to L. Okay, so this is the equation, minus K into A into dt by dx. So we have to take the dt by dx at x is equal to L. Okay, where ACS is nothing but cross section area for heat conduction. Cross section area for heat conduction. Okay. Then ही जी काय heat conduct झालेली आहे, तीच heat काय होणार आहे, convect होणार आहे into the surrounding. So as fin is losing heat at the tip, it should be convection. And how to calculate that? Q is equal to H into surface area into T minus TA. Okay, आपण separate equation लिहिलेलं आहे कंडक्शन साठी and convection साठी. Okay, what is the equation of the conduction? K into A into dt by dx at x is equal to L. Similarly, at the end heat is transferred due to the convection. So what is the equation of the convection? That is H into A into T minus TA. T minus TA. ओके, इथं ASU म्हणजे काय असणार आहे? सरफेस एरिया फॉर कन्व्हेक्टिव्ह हीट ट्रान्सफर. ASU is nothing but surface area for convective heat transfer. ASU surface area for convective heat transfer. Convective heat transfer. Okay, so according to the second boundary condition मध्ये आपण काय कन्सिडर केलेलं आहे? Conduction is equal to convection. So therefore equate that two equations. So we get the minus k into cross section area dt by dx at x is equal to L is equal to h into surface area into T minus TA. This is the equation number 3. Okay, तर मी मगाशी सांगितल्याप्रमाणे क्रॉस सेक्शन एरिया आणि सरफेस एरिया काय असणार आहे? सेम असणार आहे. सो इन दिस केस ACS and ASU both are same. In this case cross section area and surface area both are same. So therefore cross section area is equal to surface area. त्यामुळे काय होणार आहे? एरिया कॅन्सल होणार आहे. So what is the remaining equation? Minus k into dt by dx at x is equal to L is equal to h into bracket T minus TA minus k into dt by dx at x is equal to L is equal to h into bracket T minus TA. Okay, so we have to calculate the value of dt by dx at x is equal to L. So therefore we have to take the negative sign and k at the right hand side. So therefore at the right hand side minus h into T minus TA divided by k is there. हे दोन्ही इक्वेशन सेमच दिलेत, रिपीट लिहू नका. ओके, सो T minus TA म्हणजेच काय आहे? आपण काय कन्सिडर केलेलं आहे? थीटा इज नथिंग बट T minus TA. So instead of T minus TA we have to put the value of theta. So therefore dt by dx at x is equal to L, that is minus h into theta divided by k. This is the equation 4. त्यालाच काय म्हटलेलं आहे? इक्वेशन नंबर 4. ओके, आता आपण काय केलेलं आहे बघा, whatever the second boundary condition is there, by using that second boundary condition we have calculated the value of dt by dx at x is equal to L. So what is the value of dt by dx at x is equal to L? Minus h into theta divided by k. आपल्याकडे आणखी एक इक्वेशन आहे, that is governing equation. So by using that governing equation we have to calculate the value of dt by dx at x is equal to L. आणि त्या दोन्ही व्हॅल्यू आपल्याला काय करायचे आहेत? इक्वेट करायचे आहेत. ओके, so by using that governing equation now we have to calculate the value of dt by dx. Okay, so what is our governing equation? Theta is equal to c1 e raised to mx plus c2 e raised to minus mx. So what is the value of theta? Theta is nothing but T minus TA. So therefore T minus TA is equal to c1 e raised to mx plus c2 e raised to minus mx. Okay, तर याचे डेरिव्हेटिव्ह घ्या and find out the value of dt by dx at x is equal to L. ओके, म्हणजे आपल्याकडे इक्वेशन 4 आहे. that equation 4 is nothing but dt by dx at x is equal to L. So similarly by using this governing equation we have to calculate the value of dt by dx at x is equal to L. Okay, so now differentiate this equation. So by differentiating we get the equation as a dt by dx is equal to c1 e raised to mx into m plus c2 e raised to minus mx into minus m. c1 e raised to mx into m plus c2 e raised to minus mx into minus m. Okay, so our aim is to calculate the dt by dx at x is equal to L. So therefore in this equation instead of x we have to put the value of L. Instead of x we have to put the value of L. Okay, so therefore we get the equation as a dt by dx at x is equal to L is equal to c1 e raised to ml into m plus c2 e raised to minus ml into minus m. Okay, so take the common m as a common. So therefore dt by dx at x is equal to L, m into bracket c1 e raised to ml minus c2 e raised to minus ml, and this is the equation 5. ओके. इक्वेशन 4 पण आपण फाइंड आउट केलेलं आहे, dt by dx at x is equal to L. Now we have to calculate the equation 5, that is same, that is dt by dx at x is equal to L. So in equation 4 and 5, left hand sides are same, so therefore we have to equate the right hand sides. Okay, so what is the right hand side of the equation 4? That is minus h into theta divided by k. And what is the right hand side of the equation 5? That is m into bracket c1 e raised to ml minus c2 e raised to minus ml. Okay, so put that values from equation 4 and 5. From equation 4 and 5, minus h into theta divided by k, m into bracket c1 e raised to ml minus c2 e raised to minus ml. Okay, so what is our governing equation? Theta is equal to c1 e raised to mx plus c2 e raised to mx. So we have to consider that theta at L, theta at x is equal to L. So how to write theta at x is equal to L? So instead of x, we have to put the value of L. Okay, once again, theta at x is equal to L is equal to c1 e raised to ml plus c2 e raised to minus ml. हे समजले का बघा? आपलं जनरल इक्वेशन काय आहे? थीटा इज इक्वल टू c1 e raised to mx plus c2 e raised to minus mx. But we have written this equation for or at x is equal to L. So therefore, instead of x, we have to put the value of L. So therefore, theta at x is equal to L. We get the equation as a c1 e raised to ml plus c2 e raised to ml. समजलं का बघा? कारण आपण काय केलेलं आहे, dt by dx हा जो फाइंड आउट केलेला आहे तो x is equal to L ला फाइंड आउट केलेला आहे. So therefore, we have to calculate the theta also at x is equal to L. So therefore, theta at x is equal to L is nothing but c1 e raised to ml plus c2 e raised to ml. So this is our equation. So in this equation, we have to put the value of theta as c1 e raised to ml plus c2 e raised to minus ml. हे जे इक्वेशन आहे याच्यामध्ये जो थीटा आहे तो थीटा कुठला असणार आहे? थीटा at x is equal to L. So therefore, we have written the theta at x is equal to L. This is the equation. So we have to put this value into this equation. या इक्वेशनच्या थीटाच्या जागेला आपल्याला हे व्हॅल्यू पुट करायचे आहे. Okay, so all of you put that value. So what is the equation? Minus h divided by k into m. हा m जो right hand side ला होता तो left hand side ला घेतलेला आहे. Okay, so therefore it is at the denominator, that is m. थीटाच्या जागेला काय लिहायचं आपल्याला? Instead of theta, we have to put this value c1 e raised to ml plus c2 e raised to minus ml is equal to c1 e raised to ml minus c2 e raised to minus ml. Okay, from equation 1 आपल्याला काय व्हॅल्यू मिळालेली आहे? theta 0 is equal to c1 plus c2. Okay, so now what is the value of c2? c2 is equal to theta 0 minus c1. तर ह्या इक्वेशन मध्ये आपण काय करणार आहे? c2 च्या जागेला theta 0 minus c1 पुट करणार आहे. Okay, so all of you write down from equation 2 theta 0 is equal to c1 plus c2. So therefore, c2 is nothing but c2 is equal to theta 0 minus c1. So in this equation, instead of c2, we have to put the value of theta 0 minus c1. इथं c2 च्या जागेला काय पुट करायचं आपल्याला? Instead of c2, we have to put this value theta 0 minus c1. Okay, so put in above equation, put this value of c2 in this equation. या इक्वेशन मध्ये c2 ची व्हॅल्यू करा, पुट करा. व्हॉट इज द व्हॅल्यू ऑफ c2? दॅट इज थीटा 0 minus c1. ओके, काय ते बघा इक्वेशन मायनस h upon k into m c1 e raised to ml. c2 च्या जागेला काय पुट केलेलं आहे? थीटा 0 minus c1 e raised to minus ml is equal to c1 e raised to ml minus theta 0 minus c1 e raised to minus ml. हे सिम्प्लिफाय करा. काय ते बघा इक्वेशन. आपल्याला c1 आणि c2 च्या व्हॅल्यूज फाइंड आउट करायचे आहेत. त्याच्यासाठी आपण हे सिम्प्लिफिकेशन करतोय. ओके, सो multiply this bracket by e raised to minus ml. So what is the equation? Minus h upon km into bracket c1 e raised to ml plus theta 0 e raised to minus ml minus c1 into e raised to minus ml is equal to c1 e raised to ml minus theta 0 into e raised to minus ml minus minus plus c1 e raised to minus ml. हे सिम्प्लिफाय करून इक्वेशन लिहिलेलं आहे. C1 इज इक्वल टू C1 इंटू ब्रॅकेट e रेस टू ml प्लस e रेस टू मायनस ml प्लस h बाय k इंटू m इंटू ब्रॅकेट e रेस टू ml मायनस e रेस टू मायनस ml is equal to theta 0 into e raised to minus ml into bracket 1 minus h by k into m. हे तुम्ही सिम्प्लिफाय केलं, C1 च्या टर्म एका साइडला घेतलं तर तुम्हाला हे इक्वेशन मिळतंय. ओके, ऑल ऑफ यू डू दिस सिम्प्लिफिकेशन बाय yourself. So we get this equation, and from this equation what is the value of C1? C1 ची व्हॅल्यू काय येते बघा. C1 is equal to theta 0 e raised to minus ml into bracket 1 minus h upon km divided by e raised to ml plus e raised to minus ml plus h by k into m into bracket e raised to ml minus e raised to minus ml. Okay, so this is the value of C1. And what is the equation of the C2? C2 is nothing but theta 0 minus C1. So in that equation we have to put the value of C1 and find out the value of C2. आले का बघा C1 ची व्हॅल्यू. Okay, then write down the value of C2. So what is the equation of the C2? That is theta 0 minus C1. So from this we get the value of C2. C2 ची व्हॅल्यू काय येते बघा. अशी व्हॅल्यू येऊ शकते का C2 ची. सिम्प्लिफाय करा, मी डायरेक्ट आन्सर लिहिलेला आहे. C2 is equal to theta 0 into bracket e raised to ml. इथं बघा C1 च्या व्हॅल्यू मध्ये काय e raised to minus ml आहे, इथं काय आलेलं आहे e raised to ml आहे. इथं 1 minus h upon km आहे, इथं काय आलेलं आहे बघा 1 plus h upon km. हे सिम्प्लिफाय केले की तुम्हाला आन्सर मिळेल. C2 is equal to theta 0 into e raised to ml into bracket 1 plus h by km divided by e raised to ml plus e raised to minus ml plus h by km into e raised to ml minus e raised to minus ml. Okay, so what is our equation? Theta is equal to C1 e raised to mx plus C2 e raised to mx. So in this equation we have to put the values of C1 and C2. या इक्वेशन मध्ये C1 आणि C2 च्या व्हॅल्यूज पुट करा. Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. Theta is equal to C1 e raised to mx plus C2 e raised to minus mx. Okay, so put the values of C1 and C2. या व्हॅल्यू पुट केल्या की तुम्हाला इक्वेशन मिळेल थीटा अपॉन थीटा 0 इज इक्वल टू e रेस टू m. ज्यांना कुणाला सिम्प्लिफाय करायचं असेल तर तिथे जागा सोडा, तुमचे तुम्ही सिम्प्लिफाय करा, तुम्हाला हेच इक्वेशन मिळणार आहे. थीटा अपॉन थीटा 0 इज इक्वल टू e रेस टू m इंटू ब्रॅकेट l मायनस x प्लस e रेस टू मायनस m इंटू ब्रॅकेट l मायनस x प्लस h अपॉन k इंटू m इंटू ब्रॅकेट e रेस टू m इंटू ब्रॅकेट l मायनस x मायनस e रेस टू मायनस m इंटू l मायनस x divided by e raised to ml plus e raised to minus ml plus h by km e raised to ml minus e raised to minus ml. Okay, so divide this equation by 2. 2 ने डिवाइड करा. 2 ने डिवाइड केलं तर मगाशी जे कालचे जे फॉर्म्युले लिहून दिलेले आहेत ते फॉर्म्युले यूज करा. तुम्हाला काय मिळते बघा. So e raised to m into bracket L minus x. त्या टर्मच्या जागेला काय येणार आहे cos hyperbolic m into bracket L minus x. Okay. Similarly, h by km is there, and e raised to m into bracket L minus x minus e raised to minus m into L minus x. That is nothing but sine hyperbolic. So therefore, sine hyperbolic m into bracket L minus x. Similarly, for the denominator, e raised to ml plus e raised to minus ml. Upon divided by 2 केलेला आहे. So therefore, instead of that, we have written the values in the form of cos hyperbolic and sine hyperbolic. Okay, so from this, instead of theta, we have to put the value of t minus ta. What is the value of theta 0? T0 minus ta. So we get this equation, and this is nothing but temperature distribution equation when the heat transfer at the end of the tip, when the heat transfer is due to the convection. Okay, ज्यावेळेला एंडला कन्व्हेक्शन मुळे हीट ट्रान्सफर होणार आहे त्यावेळेला जर टेम्परेचर डिस्ट्रीब्यूशन फाइंड आउट करायचं असेल at that time we have to use this equation t minus ta divided by t0 minus ta is equal to cos hyperbolic m into bracket L minus x plus h upon km into sin hyperbolic m into bracket L minus x divided by cos hyperbolic ml plus h by km into sin hyperbolic ml. Okay, so this is the temperature distribution equation. आता ह्याचा यूज करून आपल्याला काय फाइंड आउट करावं लागेल सांगा Q find out करायचं आपल्याला. Okay, so this is the equation of the temperature distribution. So take the derivative and find out the Q. Q चे इक्वेशन काय असते सांगा. What is the equation of the Q? Minus k into a into dt by dx at x is equal to 0. 0 काय घ्यायचं तर बेसला आपण काय करतोय कंडक्शन होत असते. So at the base we have to dt by dx at x is equal to 0. Okay, so write down heat transfer rate. Heat transfer rate Q fin is equal to heat transfer rate Q fin is equal to minus k into cross section area dt by dx at x is equal to 0. Q fin is equal to minus k into cross section area dt by dx at x is equal to 0. dt by dx at x is equal to 0. Okay, so for the finding the dt by dx at x is equal to 0. So this is our temperature distribution equation. Okay, so by using this temperature distribution equation, we have to find out the value of dt by dx at x is equal to 0. या इक्वेशनचा यूज करून आपल्याला काय फाइंड आउट करावं लागेल. By using this equation, find out the value of dt by dx at x is equal to 0. The equation लिहा. How to write this equation? T minus Ta is equal to T0 minus Ta cos hyperbolic m into L minus x plus h by km sin hyperbolic m into bracket L minus x divided by cos hyperbolic ml plus h by km into sin hyperbolic ml. So take the derivative of this equation and find out the value of dt by dx. Okay, ह्या इक्वेशन वरून आपल्याला काय फाइंड आउट करायचं आहे. By using this equation, find out the value of dt by dx. Okay, so take the differentiation of this equation. Anyone tell me what is the derivative of this term? काय डेरिव्हेटिव्ह सांगा. त्याच्यामध्ये कॉन्स्टंट काय असणार आहे. T0 minus Ta is the constant. Then denominator also constant because x is not there. So cos hyperbolic ml plus h upon km into sin hyperbolic ml. This is also constant. So we have to take the derivative of numerator only. So cos hyperbolic m into bracket L minus x. What is the derivative of cos hyperbolic x? Sin m into bracket l minus x into काय येणार सांगा into minus m. Similarly, what is the derivative of sine hyperbolic mx? Sine hyperbolic x काय derivative आहे सांगा फॉर्म्युला बघा की कालचे मायनस निगेटिव्ह आहे का पॉझिटिव्ह आहे बघा and signs positive is na? Okay, so all of you take the differentiation. So dt by dx is equal to t0 minus ta. What is the derivative of cos hyperbolic m into bracket l minus x, that is sin hyperbolic m into bracket l minus x into minus m plus h by km. What is the derivative of sin hyperbolic m into bracket l minus x, that is cos hyperbolic m into bracket l minus x into minus m divided by constant is there, that is cos hyperbolic ml plus h by km into sin hyperbolic ml. Okay, but our aim is to calculate the value of dt by dx at x is equal to 0. So in this equation we have to put the value of x as a 0. So therefore dt by dx at x is equal to 0, dt by dx at x is equal to 0, that is t0 minus ta into minus m. x ची व्हॅल्यू 0 पुट केल्यानंतर आपल्याला काय मिळणार आहे sin hyperbolic ml plus h by km into cos hyperbolic ml divided by cos hyperbolic ml plus h by km into sin hyperbolic ml. Okay, so this is the value of dt by dx at x is equal to 0, and what is the equation of the q fin minus k into a into dt by dx at x is equal to 0. In that equation, instead of dt by dx, we have to put this value. So therefore q fin is equal to minus k into cross section area into this term. Okay, minus k into cross section area dt by dx च्या जागेवर आपल्याला काय पुट करायचं, we have to put this value. Okay, so therefore q fin is equal to minus k into cross section area t0 minus ta into minus m into sin hyperbolic ml plus h by km cos hyperbolic ml divided by cos hyperbolic ml plus h by km into sin hyperbolic ml. Okay, so what is the value of m? m ची व्हॅल्यू काय असते स्क्वेअर रूट ऑफ p into h divided by k. ती व्हॅल्यू पुट करा, हे मायनस मायनस प्लस होईल, मायनस k is there, minus m is there, so plus is there, so put the value of m. So what is the value of m? That is h into p divided by k into cross section area, h into p divided by k into cross section area Okay, so by simplification we get the equation as a q fin is equal to square root of h into p into k into cross section area into bracket t0 minus ta into that term. Okay, तुम्ही तिन्ही केस बघा, प्रत्येक केस मध्ये हे इक्वेशन कॉमन आहे, स्क्वेअर रूट ऑफ h into p into k into cross section area t0 minus ta. केस 1 मध्ये फक्त हेच इक्वेशन आहे, केस 2 मध्ये काय येते ऍडिशनल टॅन हायपरबोलिक ml येत आहे, आणि केस 3 मध्ये ही टर्म ऍडिशनल येते, लक्षात ठेवा. ओके, सो दिस टर्म इज कॉमन इन ऑल 3 केसेस. square root of HP K into cross section area into bracket T0 minus TA. cos hyperbolic ml ने या इक्वेशनला डिवाइड केलं तर काय मिळेल सांगा. sin hyperbolic ml ला cos hyperbolic ml ने जर डिवाइड केलं तर इथं काय होणार आहे. tan hyperbolic ml इथं काय होईल सांगा. cos hyperbolic ml divided by cos hyperbolic ml म्हणजे ते 1 होणार आहे h by km. At the denominator cos hyperbolic ml is there, so cos hyperbolic ml 1 is there plus h by km into tan hyperbolic ml. So all of you write down divide by cos hyperbolic ml divide by cos hyperbolic ml. Okay, so by dividing cos hyperbolic ml we get the equation as a square root of hp ks k into 8 t0 minus ta tan hyperbolic ml plus h by km divided by 1 plus h by km into tan hyperbolic ml. Okay, all of you get this. This is the case number 3. समजले का? What are the 3 cases? Can anyone tell me? What about case 1? Case 1 मध्ये आपण काय कन्सिडर केलेलं आहे? Fin is infinitely long. Okay. What about the case 2? The end of the fin is insulated. And in case 3, heat is convected or heat is transmitted at the end of the tip due to the convection. जो काय एंड असणार आहे तिथून हीट जी ट्रान्सफर होणार आहे ती कशामुळे ट्रान्सफर होणार आहे ड्यू टू दी कन्वेक्शन. सो दीज आर दी 3 केसेस. तुम्हाला एखादा प्रॉब्लेम दिला तर कुठल्या केसचा प्रॉब्लेम आहे हे अगोदर समजलं पाहिजे. लक्षात ठेवा. लॉंग, इन्फायनाइटली लॉंग. इफ दिस वर्ड्स आर देयर then we have to remember this is the case number 1. Okay. Second case मध्ये तुम्हाला काहीच मेन्शन केलेलं नसणार आहे. Infinitely long is not there and convection is not mentioned there. So at that time we have to use the case number 2. Okay. So now we have to solve one problem related to the case 3. Okay. इथे मेन्शन केले बघा. The convective coefficient is 40 watt per meter square. So we have to remember that if convection is mentioned, so at that time we have to use the case number 3. Okay. Because at the end heat transfer takes place due to the convection, and this is our case number 3. So whatever the equations for the case number 3, we have to use that equations and find out the values. Okay, so all of you write down this problem. Write down a motor body 360 mm in diameter. A motor body 360 mm in diameter, that is outside. A motor body 360 mm in diameter and 240 mm long and 240 mm long and 240 mm long. Full stop. Its surface temperature should not exceed. Its surface temperature should not exceed 55 degrees Celsius. Its surface temperature should not exceed 55 degrees Celsius. 55 degrees Celsius when dissipating 340 watt. Its surface temperature should not exceed 55 degrees Celsius when dissipating 340 watt. Full stop. Longitudinal fin of 15 mm thickness and 40 mm height are proposed longitudinal fin of 15 mm thickness and 40 mm height are proposed 40 mm height are proposed full stop. The convective coefficient is the convective coefficient is the convective coefficient is 40 watt per meter square degree Celsius. 40 watt per meter square degree Celsius. Full stop. Determine the number of fins required. Determine the number of fins required. Determine the number of fins required. Full stop. Atmospheric temperature is 30 degrees Celsius. Atmospheric temperature is 30 degrees Celsius and K is equal to 40 watt per meter degree Celsius. K is equal to 40 watt per meter degree Celsius. Okay. हा प्रॉब्लेम आपण नेक्स्ट लेक्चरला सॉल्व करूया. त्यातला एकच पॉइंट राहिलेला आहे फक्त इफिशियन्सी अँड इफेक्टिव्हनेस ऑफ द फिन्स. ओके, सो इन टुमॉरोज लेक्चर वी कॅन कन्क्लूड द युनिट नंबर 2. Okay, so those who are online present, put your roll numbers in the chat box. Okay, so तुम्हाला एक नोटीस पाठवलेली आहे मगाशी. In that notice one link is there, so all of you join that lecture. Join करा सगळे. आता जॉइन करायचं, जॉइन करा सगळे.
लेक्चर लिंक ना
55 11 34 52 36 20 next 58 57 19 huh 37 46 56 51 67 65
नंबर
next huh 13 18 33 first bench 49 10 कोण राहिले का आणि रोल नंबर सांगायचं. बसा की पुढचं बघ.